Hello, this is a video for SOEN6441, Advanced Programming Practices. This is for week 8. Now I'm going to be talking about refactoring. So I already mentioned that earlier in the course, so now we're going to go into more details about what refactoring is. I'm not going to go into all the details. You have to understand that this is the kind of topic you may spend an entire course on. The thing is, refactoring is essentially a programming activity, right? It is about reorganizing your code to which for better quality of organization of your code. So as it is a coding activity, and this course is of course a programming kind of course, programming and a software engineering context kind of course. So, and we're also doing Agile methodology of project management. Refactoring is very much related to that, as we saw in extreme programming. There is a key feature, very important key feature, which is actually refactoring. So here we go. The topic. What is refactoring? Refactoring is a technique. First of all, it's a disciplined technique in the sense that it requires organization. Okay, it's not improvised. Refactoring is not an improvised technique. It's a disciplined technique for restructuring an existing body of code, altering its internal structure without changing its externally observable behavior. So it's not about like debugging. It's not about looking at your code and fixing things randomly. It is a disciplined technique that you use to restructure your code. You should verify that the code is behaving in a certain appropriate way before, then you make the change, and then you verify that it's actually behaving in exactly the same way after. So that, for example, that's for that reason that it excludes that is debugging. Whereas when you debug, by definition, the software behaves in a certain way, erroneous manner. You debug, and then after the debugging, it behaves in a different manner, which is the correct manner. So debugging is not refactoring. There's very often myths about what is refactoring. Here I'm talking about the disciplined approach of refactoring. So refactoring does not fix bugs, but it may help to fix bugs. Well, one of the things you have to do when you do refactoring is to figure out, first of all, if you are to improve the quality of your code, the structural quality of your code, you have to inspect the code. Now, anytime you inspect your code, you are likely to actually find bugs. So it's possible that as you do the refactoring, you will find bugs, in which case you may want to fix them. But that does not mean that refactoring is about fixing the bugs. It just enabled you to find a bug. It may also, it may help to have fewer amount of bugs in the code because you make your code more orderly. And very often when you have bugs, sometimes it's due to the fact that your code is messy. And it's hard to understand how it should behave and how it should be organized. Sometimes you make mistakes because of the mess, and then you introduce bugs. Okay. So the more the whole software is well organized, less is possible that it will have bugs. Having good, that being said, having good organization is not going to ensure that you don't have bugs. That's not what's to be said. Refactoring does not add new functionality to the system. So don't call refactoring the addition of things to your code. Okay? Anytime you add something externally visible to the code, it is not refactoring. So one of the things I'm going to be asking, as I explained earlier when I gave the video, the lecture about the state pattern and the command pattern, I'm going to ask you that one of your refactoring operations should be to actually introduce the command pattern and the state pattern in your existing design. Very important that you understand that the operation should be that you have an existing design now. The software works with this existing design. It works in a certain, externally visible way from the user's perspective. It already works in a certain way. Now, what I want you to do is to change the internal structure of the software, for example, by adding the state pattern, so that as the user will use it after the state pattern has been introduced, the user shall see nothing different. Okay? That you should not actually change the behavior of the software. So that's a classic characteristic of a refactoring operation. Improves the quality of the internal structure of the software without changing externally visible behavior. It is, as we saw when we discussed about extreme programming, refactoring is an essential aspect of incremental software development. So as we saw before, this is incremental software development loop here. And then, of course, refactoring is this very crucial step in between the deployment of a build and the starting of the next build. Okay. Very important that you understand that this refactoring operation here, it's not part of developing new things in the system. You deployed the system in a certain state, then you apply refactoring on the internal structure of your software before you start the development on the new iteration, on the next build. And only when you finish the refactoring, which should not change anything in the features of the existing features of the system, then you actually begin the development of the next iteration that is going to add some features to the software. So when should you do refactoring? Factoring ought to be done continuously as you encounter what is called bad smells. So bad smells is it's a dedicated term in the research area of refactoring. There are many researchers in software engineering that are working in how to, like for example, automate refactoring operations. We have a very important member of this community in our department, Dr. Santalis. He's very famous in this community and researchers on refactoring. So yeah, so you're doing your implementation, and then sometimes there are some indicators if you have some experience, you find some indicators that there is some places in your code that may need to be improved, structurally speaking. Okay. The more experience you have, the more you can detect those, and you can actually, as you go, you can actually do some refactoring as you go. You don't have to wait necessarily for the refactoring operation between the builds. Though one of the things you should not, if you choose to do them as you're doing the coding, you should not let refactoring actually slow you down, because as we said earlier, when you're using Agile development, the focus should be to produce more code, to add more functionality. Again, refactoring is not adding functionality. So arguably you are coding, but you're not adding to functionality. So that's why you should balance doing refactoring while you code. maybe you'd better spend more time producing new code rather than fixing existing code, which prevents you from writing new code. So the bad smells are essentially, they are anti-patterns. So you see in the code, there are some indicators, some patterns that you can detect that are actually indicative that there is potentially something that can be improved in the design of the code. So eventually what you want to do is to identify refactoring targets. So either by your own experience, so you may have a meeting with the team, or as you go, you may take note of the things that you think should be improved, structurally speaking. All this to say, or there's also tools that may help you, that you can run a tool that will look at your code and then identify some places where some analysis have identified that some parts of your code may need to be refactored. So there are tools that can help you to identify refactoring targets. If you take Dr. Santali's course on refactoring, you certainly will use these tools, but this is not the focus of this course here. So here, I'm just basically going to ask you select some refactoring targets, however you want, by discussing with team members. I'm going to propose to you some refactoring targets. Then I'm going to expect that you will do these refactorings in between the two builds, and that you will somehow report as you will do for example, as you will do this presentation of the second build, you will have to report on the refactoring operations that you did between build number one and the start of build, between the end of build number one and the start of build number two. So if, as is our case, if you're using incremental software development, then the most important refactoring phase, I might say, should be in between the builds. Okay. So I remind you that why is this the case, that it's very important in Agile software development, because most of these, when you're working using builds or sprint or whatever is the term that you use in incremental software development, the focus is on speed of production. You want to produce code as rapidly as possible and meet your deadline for the next build. Yeah. So when you are, your focus is on speed, then of course you are likely to implement suboptimal design solutions. So it's possible that after the build will be finished, that yes, it's going to work, but it is kind of shaky in some places, design speaking. Okay, so that's why you have to look before you start the next build. Then you look at your code and you fix things so that it actually is proper before you continue on the next build. If you don't do that, then this is where I was describing this graph here, which I will come back to a little bit later. If you don't do refactoring operations and you use incremental software development, you are inevitably going to run into some trouble. So refactoring in incremental software development, very important for actually the survivability of the entire project. So why would you do refactoring? So refactoring is usually done to improve the quality. There's many qualities that can be improved by refactoring. Of course, they're all related to the improvement of the design quality of the code. If you improve the design quality of the code, it may improve maintainability because it improves the readability of the code. It makes the code more easy to change. It makes the code more easy to extend. It's also improving the testability of your code. As you do refactoring, as I will mention later on, you actually need tests. So it's possible if you want to, it's necessary if you want to apply some refactoring operation on a part of your code, that you have some tests specifically for this part of the code. So if you want to apply a refactoring operation here and you don't have tests for this, then you have, first step is you have to write some tests for this. You test that it's working properly. You apply the refactoring operation, then you test again to see if it still behaves in the same manner after the refactoring. So it actually makes you write more tests potentially on your code, which is a good thing. It also may help to find bugs. Again, the key word here is help. The goal is not to find bugs or to fix the bugs. You will scrutinize your code. For example, as I just said, maybe you're gonna target a certain aspect of your code for refactoring, then you will write more tests to test it properly. Maybe you're gonna figure out that there was a bug in this piece of code, then you're gonna fix the bug. The fixing of the bug is not a refactoring operation. It's kind of a corollary, if you want, of the operation, or side effect of the operation. Then it also improves, why doing refactoring? Another reason, it improves productivity. So as your code is more maintainable, more extensible, more readable, it will eventually improve your productivity in terms of lines of code that you can produce in the short term after you did the refactoring operation, as well as potentially also in the longer term. So it essentially also simplifies the structure of your code. Sometimes when you proceed, when you're in a rush to work on the next build, and you do things quickly, maybe they work, but they are kind of messy. So, and more complex to understand and deal with, and takes time to deal with messy code. So if you fix it, then you actually reduce the amount of time you have to spend to deal with part of your code that might be messy. As well, I mentioned briefly mentioned about the graph here that I have here. It actually improves the sustainability of the development in your project. Now, what does that mean? So as you develop software, inevitably, as you are adding more lines of code, when you start, it's actually when you start the development, writing the first lines of code actually goes pretty fast. But the more you already have lines of code, the more it actually takes more time to write more lines of code that will have to deal with the lines of code that you already have. So the lines of code that you already have acts as some kind of constraints on your future development. And also, the more the lines of code that you have potentially are more messy, the more it actually takes more and more and more time to develop new lines of code for this project. So essentially, what happens is that the cost, so here, this is the effort in terms of cost of writing new lines of code, it actually goes, generally speaking, always on a slope like this. Now, if you proceed in a very fast-paced manner, as is advocated by Agile and incremental software development, you are actually making it so that this curve here is going to be more and more exponential. And more you are sloppy in your development of code, the more you write messy code, the more this slope is actually more and more exponential. Okay. Now, the point is that as you develop software, you are, and if you're developing software for a company, the company has a budget to actually develop this software. So this is the total budget that you are given to work on a certain project. Okay. The point is that if this line actually reaches this other line here, then basically you have ran out of money. Now, if this line here is the actual finish line of the project, and then this line intersects this line here before this line here, what that means is that you ran out of money for this project and you have to stop even though it's not finished. Okay. That means that whatever you were doing as an activity to develop code here, if you reach that here, this activity was not sustainable. It was impossible for you to actually come to the finish line by continuing to work as you were working. So if you want to make it sustainable, you have to find a way to somehow make this line here less exponential so that it has a chance to actually reach, or potentially, of course, potentially you want to make a profit. So the more you actually reach the finish line, the more there's space between this line here and the intersection between your cost here, the more you have a profit margin. Okay, so you want to somehow lower this line here, make this line more flat so that you reach this line here and you have a better profit. Okay. So that's the general concept of sustainability of development. If you reach this line here, the top line before the end, whatever you were doing was not sustainable. There was going to be inevitably something wrong that would happen before you could finish. The project would have to be discontinued before it was actually finished. So how does this, why is refactoring enabling sustainability of development? So as it improves the code's structural quality, it actually reduces the confusion as people are working so they can be more productive. It makes the code more understandable, and it actually overall reduces the effort to work on the existing code base like every day. So that has the effect of overall to make it more easy to work with this code. That's basically what it's saying. So that's very important Agile software development methods, which focus on productivity. So of course, we all know that when you do things more faster, you're doing things more sloppy. Maybe they work, but they're not very pretty. And then if you pile up things that are not pretty, then that makes it more and more and more difficult to actually deal with them and to even improve them over time. If they become so disorganized that it becomes very difficult to start organizing them even. So you have to do this reorganization as you go and not wait until it's so much of a mess that cannot be fixed. Okay, so you have to do it regularly. You have to do the reorganization regularly as you go. There's no point, for example, to wait until you are here to actually do the reorganization. Okay, it's likely that if you are here, it's going to cost you a lot to actually do the reorganization. So the trick is actually do a part of reorganization as you go, as you are going, and not wait until it's too late. So without refactoring, Agile methods are likely to create code for which it may become impossible to continue working on it, or that the slope is going so exponential that it becomes impossible to stop the trend. Okay, so eventually what you do is here is your different builds. Like this is build 1, build 2, build 3, and then the final build. So if you actually implement between each of the builds, you implement this refactoring operation, then the effect, well, this is a very simplistic way of explaining it, but the effect is that eventually it's gonna, if you are set up on this curve here and then you do a refactoring, then what's eventually happening is that the curve starts back again a little bit lower, because here the code was messy. Here you made it more easy to work with. So now after this refactoring, you start here from after you build number one. Then it continues to increase as it will always will. But as you deliver the second build, then you can do another refactoring operation, thus bringing the slope again a little bit lower. Then you continue again. So you see that the slope between this and this is rather the same, and between this and this, it's rather the same. But because you actually lower it a bit every time, you eventually, that makes a difference between here you ran out of money and here you made a profit. Okay. So it can increase your profit, and it can also reduce the possibility that you will run out of money on this project and you might have to terminate the project before it finishes. So that's what is, strategically speaking, the importance of refactoring. So how do you do refactoring? What is this procedure? Because it is, you have to understand it as a procedure, a well-organized procedure. So each refactoring is actually a small behavior preserving transformation. So it's a transformation of your code. Okay, so you take your code, your existing code, and you transform the code so that it works in a different way, but it actually is preserving the behavior, the original behavior of the code before the refactoring. So you're essentially rewriting the code so that it behaves in this, it behaves in the same way. It produces the same thing, same externally visible behavior, but it actually is organized in a different way to achieve the same thing. So how do you check that it is actually behavior preserving? By actually testing before and after. So you want to have your existing design, test it using unit testing, and checking that it behaves correctly before the transformation. Then you make the transformation, then you test it again. It's essentially a process of test, refactor, test. So here you have your code base, you have your tests. If, of course, if some tests fail, then you would debug, but that's not part of your refactoring operation. Okay, it's just a side effect of applying the tests. So after you fix the bugs, if you find some, because I remind you that if you want to do, let's say you want to do refactoring on this code base here, and you don't have tests, first thing you should do is to write tests. By writing these tests, maybe some of the tests will fail. Then you will have to debug. Okay. Very important, I cannot emphasize this enough, is that if you do refactoring and you don't test, you're not doing refactoring. This cannot be called refactoring. It's not, you're fixing the code and so on, but you're not doing refactoring if you don't test before and after. Then, of course, it's possible that you will change the way that the software is organized, and then you will test again, and then you'll realize, oh, you made a mistake as you made the change. Then you will actually fix the mistakes that you made as you implemented the change. That's why the tests are important, because if you change the code, we all know every time you change code, that you run the chance that you, even though you might think everything is correct, that you make the change correctly, you may run the chance that you will break the way that the code was working. Maybe it was working before, your good intention, you want to fix something, and then you don't realize, but you broke the code. Okay. So how would you realize that? By testing after. That's why it's very important to have the tests. So you might say, well, there seems to be a lot of advantages to it. What is the drawbacks to refactoring? Of course, this is an activity. So example, you have to identify what are the refactoring operations that you will apply. So you have to select them. You have to have a meeting with the team, decide which refactoring operations you will do. Then when you identify a certain code base that you will refactor, then you need to have tests. Maybe you have to write new tests in order to apply the refactoring. There is overhead to this procedure. Okay. So there's a cost related to implement refactoring. So what you want to do is for anything that you add as cost, so the idea is that your objective is that you want to prevent that the cost overruns too much and that it comes here. So what you want to do is to invest some time in refactoring. Yes, it's going to increase your cost a little bit, but what you want to do is that overall, even if you add the cost of the refactoring, that it would still bring you lower than if you don't do refactoring. Of course, this is kind of a balance that requires experience to implement. So yes, there's cost overhead involved in implementing refactoring. So that's why if you do too much refactoring, maybe it's not, there will come a point above which more refactoring actually does not help. It's actually more costly than the benefit that it gives you. It also requires expertise. So yes, you might use tools that will point you to certain refactoring targets, but these tools would just blindly give you the list of all the things that may be refactored according to a certain automated analysis tool. So then the question becomes, which ones of these messy parts of your code are the most, how can I say, damaging in terms of a certain messy part of your code will make it so that people will spend a lot of time dealing with this messy code compared to another part, which is, yes, messy, but people will not spend that much time on this other part. So for example, if there is something very messy in a crucial part of your code that people are working on every day, and then every day, everyone is spending more time on coding because of this messy part of the code, and maybe this part is more, it's more appropriate to actually fix this part, this piece of code, rather than this other piece of code that is also messy, but which people never touch anyway, okay, or very, very seldom touch anyway. So all this to say that it requires experience, expertise in order to figure out, what is the balance between how much refactoring you should do, where you should do the refactoring, requires experience. Now here, that was the introduction of what is refactoring in general. Now here I'm going to present some what is called refactoring patterns. That doesn't mean that this is the kind of things I want you to look for refactoring targets. I'm just giving you some examples. Okay. There is, such as design patterns, there is refactoring patterns. There are actually books that are written that will characterize, identify patterns like this. And then the tools that enabled to automatically detect refactoring targets, they would actually use these patterns. Basically, you implement some kind of compiler that is looking in the code and is looking for these patterns. And then the tool will identify these refactoring patterns using their characteristics, their syntactical and semantic characteristics. So I'm not gonna go into all the details of all of these here. So first of all, refactoring pattern, for example, encapsulate downcast. So here a method returns an object that needs to be downcasted by its callers. Refactoring will move the downcast within the method. So here you have a function that returns a certain type, but it returns the super type. So here, what you want to do, and then each of the methods that are calling, each time you're calling this method, it returns something of type object. Then, of course, the method that is using the return value of this method will want to know exactly what kind of type that is in order to manipulate it. So that means that every time you're calling this method anywhere in the code, then you need to do a downcast from object to the specific kind that it has produced at this specific time. So, for example, if this method is returning something of this type here, so you much better have this type as being the return type rather than being object being the return type. So both of these pieces of code are working in exactly the same way. Okay, there's no, it's no question about it, except that this one here will force you every time you call this method to add a little bit piece of code to transform this object into this object of type object into an object of type reading. So that creates code duplication. It creates also the possibility that somebody will forget to do it, and then we'll have to spend some time figuring out why it doesn't work. So again, it's about saving effort over time. Yes, a little bit effort every time, but a little bit effort plus a little bit effort and so on adds up to hours and days of work over months. So you might have, again, I'm going to go quickly over these. So you may have several conditions that are embedded inside of the same function. So what you may want to do is to group all these conditions together inside of a function. And then this function is going to actually compute these conditions and then aggregate them in a single Boolean expression. So that if you want to change what are the conditions later, then you know that you have to only change this place here and not something somewhere inside of the code that is distributed over the code. Okay. So many of the things about refactoring is about concentrating the place where if you have to change something, you know that it's only a one place. One of the very common ways that you may make mistakes as you change code is when you have duplication of code. At several places in your code, you are doing the same operation. So if somebody wants to change what this operation is doing, then they may change only this place and forget that it's also done here. So if you change this one here, you should also change the other one here. And then somebody might not know or might forget or have forgotten that this code has been duplicated in two places, changed only this one, and then it doesn't work anymore. Okay. So very often refactoring operations are about either to avoid duplication or to create a design that is factorizing duplicated code. Here's another example. Here you have an if statement, and both in the then part of the if as also the else part of the if, you have twice the same piece of code. Here it's doing send independently of if this is true or if this is false. So essentially here, it's basically saying that send is done independently of this condition is true or false. So you should really factor out the send out of the if statement. So you see this is one of those factorization techniques that you use. There is repeating concepts like this, even though the patterns might be different. This notion of factorizing a duplicated piece of code is very frequent across different patterns. there is, as you know, if you're using an IDE, you have this refactor option, which allows you to change the name, a certain name that you have, a certain ID or class name or a function name. So you click on a function, and then you can actually automatically change all occurrences throughout all your code of this occurrence of this name. A very useful tool, is if you would have to do that manually, extremely error prone. So renaming a method to make it more appropriate is a way also to refactor code. You see that is here you're changing the readability. For example, you're improving the readability of your code by giving more meaningful names, but it has absolutely no effect on how the software is operating. Here, let's say you have a class hierarchy like this: employee, salesman, engineer, and both of the subclasses of employee, or of any other class for that matter, if the two subclasses or more, all the subclasses of a class in a hierarchy have all the same data member, then what you should do is to actually factor this data member here. Again, this is a factorization technique that is very structurally different from those that I've said before, that I presented before. So this one is called pull-up field. Another one is push down method. So if behavior on a superclass is relevant only for some of its subclasses, you should refactor it and then push it down to the class for which it is valid. Sometimes you might want to very quickly add a function. So you add it in at this level here, and then you put an if statement saying that it should only apply to objects of type salesman. So if that's the case, then what you should really do is to take this method and actually put it here. Okay. So that's it for my presentation of the refactorings. Again, this was just to give you some examples. Okay, just don't even expect that this is going to be on the exam. This was just some examples to give you a sense of what kind of transformations we're talking about. These were actually very simple refactoring operations. So in practice, the refactoring can also be controversial. If you use a tool that will actually automatically detect your refactoring operations, some of these tools will actually propose that you automatically apply a transformation. Now, it's important to realize that sometimes tools like this, or bad smells that you may detect using tools like this, you have to use your own judgment as to which of these operations that you will apply. Sometimes it may actually make your code, it may have the inverse effect. Sometimes applying this transformation, sometimes there's a good reason why you made such a decision that may be detected by a tool that detects bad smells. The tool will not know that there was a good reason why you made this decision. So if you would actually let the tool make the change automatically, maybe it's going to make the situation worse. So there are some of these refactoring operations that are controversial. Some people are, just like for any pattern, there is some controversy over some of them. Even design patterns, there is some controversial design patterns. So some of the refactoring operations can actually be counterproductive. So somebody in your team, so you may have made a decision in the design of your code, and it may appear to someone else that the code is not so well organized, but maybe this other person does not know some reason why you have organized it in this particular way. So if this person would actually change your code, then they're likely to actually run into trouble by trying to make it better. So you have to be careful when you apply transformations. Sometimes there are good reasons why it's structured in a certain way. So the way to actually do it is to have team discussions. So as you finish a build, then you have a team discussion, and then people get together and identify what are the things that everybody in the team agrees that a certain thing is very annoying and time consuming. A certain piece of messy code is annoying and time consuming. Everybody agrees this is what we're going to fix. Okay. So refactoring should not be applied by an individual whose individual opinion is that this piece of code here needs to be changed. It should be agreed by everybody in the team. Sometimes the application of a design pattern can help make better organization in your code. That's exactly why one of the things I'm going to say when I give you build number 2, I'm going to tell you have to apply the state pattern and you have to apply the command pattern in a very specific way that I'm going to explain in the build number 2 statement. Okay. So introducing design pattern to a piece of code is or can be a refactoring operation. Of course, you should use a unit testing framework such as JUnit if you are using refactoring. It requires that you do testing, as we covered before. Doing testing without a JUnit, without a unit testing framework is it's not feasible. It's not very productive. So you have to use a unit testing framework if you are doing refactoring. So how is it going to work in the project? So the refactoring operation should be done before you start working on the new build. Okay, so as a team, I'm going to give you some targets. For example, the introduction of the state pattern and the command pattern. Before you do anything else, you should concentrate on doing these refactoring operations. So what I'm going to ask you to do for build number 2, for refactoring, I'm going to ask you, provide me with a list of 15 different potential refactoring targets. So have a team discussion and come up with a list of 15 things that you think are things structurally that should be improved in your code. So a list of 15 different things. So you can do code inspections, discuss among you. If some of you know some tools that can detect automatically bad smells, then you can run the tool and can give you suggestions. Whatever you do, you must come up with a list of 15 different things, 15 different design elements that you identify could be the potential target of a refactoring operation. Then I'm going to ask you to select 5 of these from the list of 15. And then I'm going to ask you to justify why you chose these. I'm going to give you some that should have to be in the list of 5. So I'm going to give you 2, which is introduce the command pattern, introduce the state pattern. Of course, you should make sure that the tests would be available for each of these 5 different refactoring operations that you will apply. So then you have to do the refactoring operation on these 5 refactoring targets that you have identified. So basically, the first thing you do is you identify what are the classes that will need to change by this refactoring operation. Then you should identify what are the tests that are written that are actually testing the methods that will be affected by the change in the structure that you propose. If there are some methods that are to be affected by the change that don't have tests, then before you do the refactoring, you have to write new tests so that you'll be able to test before as well as after the refactoring has been applied. So after you have all the necessary tests, first you run the tests to actually prove that before the transformation it actually works correctly. Then you determine what's going to be the transformation that you will apply. Then you apply the transformation and then you run the tests again. Okay? So identify 15 potential refactoring targets and then distill them into 5 that you will apply by giving justification why you chose these 5, and then apply the transformation for each of these 5. So that's what you have to do for the project regarding refactoring. That's it for this video. Thank you.